Good morning, everyone. Am I audible to you? Okay, thank you. Okay, is there anyone have any doubt regarding the last class? Okay, today we'll discuss about this. Okay, ILD for SSB. SSB means simply supported beam. Okay, how we need to draw and how we need to calculate this in case of a simply supported beam. So we'll discuss about this. So all of you please pick out your pen and copy. If you have any doubt, you can write. Okay, it's a very simple one. So let's see how we need to analyze this kind of beam. Okay, simply supported beam. So here, as you can see, we need to consider a simply supported beam carrying a moving load, and our aim is to determine the ILD at support reaction RA and RB, and to draw the shear force and bending moment diagram at a section C, the distance Z from A. The figure shows a particular position of the moving load at the distance X from support A. Okay, so this is the simply supported beam. It is given length L. We are taking a section at C at a distance Z and a moving load that at a distance X from support A. Okay. So now see what we need to do. But first of all, what we need to do, we need to find out the reactions. Okay. I think all of you know how to find out the reaction. If you want to find RA, what we need to do, we need to find out the moment, taking moment against support B. And all of you know this, how we need to find out. It's very simple. If we are taking moment above the support B, it is simple RA into L minus unit load is given 1 into L minus X. So from this, if you calculate it, you can easily find out the RA. And RA is given by L minus X by L. It is very simple. Okay. Similarly, by resolving the horizontal forces, remember that we need to use the equilibrium equations. Okay, we are using that. If we resolve the horizontal forces, what are the horizontal forces in our this type of beam? There are only three: this RA, RB, and this one unit load. Okay, this one unit load. This and this. These are the three horizontal forces. These are in the upward direction and it is in the downward direction. So sign will be according to that. If we consider upward direction as positive, then downward direction should be negative. Okay, simple that. So from that you can easily find out the RB, RA and RB. You can easily find out by using these two equilibrium equation. Okay, so from this two equation we can easily say that what is the value of our RA and RB. Okay, so after that, what we need to do, we need to change the distance from 0 to L, means all over the span of this beam. So how we will find out this RA and RB? See, for the unit load, we have calculated RA This we need to find out now. Okay, at the range of this x less than equal, sorry, 0 less than equal x, x less than equal L. So see, when x equals 0, what it our RA, we need to put in this value. Okay, we need to put in this RA and this RB. Right? These are the two basic equations for RA and RB. So now what we need to do, if we consider x as 0, so L minus 0 by L. So L by L, it gives us what? 1. Is it? So see here, RA is 1. Okay. Similarly, again we need to find out RB. See, in this equation, if we put x is 0, so 0 divided by something, it comes out to be 0. Okay, so we need to draw by putting these things. Okay, so RA we got 1 for if we put x equals 0, and similarly again what we need to do, we need to find out x equal L by putting x equal L. Then what we will get, if we put as x as L, what will comes? L minus L will be 0, 0 by something, it gives us 0. Is it? So same way, when you put RB, x equal L, L by L is 1. Here you see, L by L is 1. Okay. So now we have to draw these two diagrams. These two diagrams are called ILD for RA and ILD for RB. Okay. Remember this. This first one is ILD for RA, and this below one is ILD for RB. Okay, by putting this value, RA is 1, here you see RA 1, RB is 0, when x equals 0, this RB is 0, when RA is 0, x equal L, this is RA is 0, RB is 1, when x equal L, this is RB is 1. Okay, very simple thing. Just we need to put this value in the above equation. Okay, so now we need to find out at that point C. Okay, what it will be come out. ILD force, shear force at C. This is called ILD for shear force at C. Okay, so now what we need to consider, we need to consider the load in different side of that point C. So first what we do, we will consider when the load is in the left side of C or x less than z, means here C. This is our beam. First we consider the load at a distance less than z. This is our z distance. So we are considering somewhere, say somewhere here. Okay, somewhere here. See this diagram. This is the simplification of that diagram. Okay, this we are considering this load less than at a z distance. Okay, so how we need to find out this FC. FC is shear force at C. Okay, shear force at C. This is at the right side of RB, and this equation we already know. If we simply find out again by taking the moment and all these things, we will get this. Okay, minus x by L. It is in the right side, so when we take moment, we will get minus RB. Okay, so just minus x by L. So you need to put the value here again similarly in the previous way. X equals 0. When you put x equals 0, you will simply get fc is 0. Similarly, when you put x equals z, fc will get z by L. Okay. Now why we are putting 0 and z? Because we are taking up to a distance z, not L. Okay. We are not considering the whole set, whole beam. Similarly, when it is in the right side of C, see here, C is here, this one C, and our load, this load is in the right side of this C. So this time Z is less than X. Similarly, FC is, if you calculate, you will get FC is nothing but equal to RA. And RA we already know what is this RA. RA is L minus X by L. So similarly, when you put F, when you put 0, you will get FC as 0 when X equals 0, and when X equals Z, you will get this equation. Okay. So after finding out this, you need to put these strings. Okay. In this diagram, you need to draw. This is the one condition, first condition, and the next condition is when X is greater than Z. See, similarly again, you need to find out same thing. You need to repeat a simple calculation. So you can easily find out this. I have already given you some notes from the book, so all of you go through that step by step. It is well explained. You can easily do that. Okay. In the next condition, what we need to do, we need to consider this unit load at the distance x, which is greater than this distance. This is nothing but z distance. So where you see x is greater than z. Okay. Next, what we need to do, we need to find out the bending moment at that section C. Okay. So for bending moment, again, first one we need to consider x is less than z. Similarly, we consider x need to x greater than z. So when we're taking the moment about RA, so it will be given by this equation RB into L minus Z. Just put the value of RB here. RB we already know x by L. This is L minus Z is simply keep like that. Next again we need to use this limit 0 less than x less than f. Same thing we need to repeat again and again. Okay. Just put the value x equals 0, what will come? It will be anything multiplied by 0, it will come 0 when x is z. Just put the z here. This equation will get. Similarly, when x greater than z, it is given by. When you take the moment, you will get this in this section. Okay, in this beam, when you consider like this, x is greater than z or x is less than z. When you take moment, you will get this. When you take moment, you will get this. Okay. So again, you need to put this value. After putting this value, you will get a ILD. This is called ILD for MC means moment at sea. Okay. And we need to draw this. If anyone have any doubt, you can ask, or we will move to the next. Just try to do this, okay, by writing. If you will not do by yourself, you will not able to understand. Just draw and try to draw do this. Things are all very simple things. I think all of you already got this simply supported, beam cantilever, beam overhanging beam, everything you already got in your previous sem. Just simply use that and try to draw this. Can move to the next, or you can start in the next class. Am I audible to you? Are you able to hear me? Okay, for your reference, you can use two books, okay, called Structural Analysis 1 and 2, and the writer is S.S. Bhabikati. Structural Analysis 1 and Structural Analysis 2 by S.S. Bhabikati. This is a very good book, very well explained, and it is in a very simpler way it is given. Okay, all of you please give your attendance in the chat box. Okay? Is there anyone left to give you attendance? And if you have any doubt, you can ask or you can wind up this class, okay, today for today. And someone is asking about author name. Okay, I am writing it up. Just wait. It's not like that you can only follow this book, okay, section analysis by SS Bhabikati. You can also follow other book also. There are so many books available. You can also download the PDF file and you can also buy that. I will give you some PDF for books. Don't worry about that. Okay, then fine. Let's wind up for today. Thank you all.